Hello everyone, my name is Charles Henry. I'm a student at Georgia Tech, currently obtaining a master's in computer science, and today I want to talk to you about the quest to replace passwords. In particular, I would like to talk about the framework developed to comparatively evaluate web authentication schemes. This should only take about 20 minutes, and without further ado, let's get into it. Okay, before I really get into the guts of this, I just want to go ahead and give a presentation acknowledgement. This paper and topic, if you will, was presented at the 2012 IEEE Symposium on Security and Privacy. And really the principal contributors listed below, which I don't want to butcher their names, but Joseph here on the left, it was the IEEE member who presented the topic. And the gentleman here on the right, the far right, I believe was his principal author. The link right there above is going to take you to the IEEE website, and you can click that and log in without having to have a subscription. Furthermore, I just want to go ahead and highlight that there is an extended paper and topic on this, and it's through the University of Cambridge, obviously outside the United States, but this topic was released in March of 2012 and really covers in a lot of depth a more thorough analysis of what we're going to go over today. But again, those two references are available for your viewing, and I'll put those in the comments so you can access them a little bit better. Going into the agenda, again, I'm going to go ahead and give you the bottom line up front. We'll go over the background, the general problem statement, some solutions, if you will, and then the conclusions and my findings at the end of the presentation. So within the web authentication realm, and quite frankly in any other authentication realm, there tends to be an inherent battle between security and usability. And in one sense, you want to be as secure as you possibly can, but on the other sense, you want to also support the end user and not make it near impossible to get authenticated. So authentication is not just a unique problem to web systems, and the framework in particular that we're going to be looking at can be extended to other systems like physical systems, cyber systems, and what have you. The paper goes into depth about really the different benefits that is established. And it provides a comparative evaluation between security, deployment, and usability. And of those, they evaluated 35 password replacements. And spoiler alert, to date, they didn't find any alternatives which benefited any existing legacy password schemes. They compared all the major password replacement concepts to include phone passwords, knowledge-based authentication, a variety of hardware tools, and nothing was better than what we have. So a little bit of background of kind of the situation, if you will. I mean, passwords have really dominated all other authentication schemes, and yet they're really plagued with security problems. Researchers and people that quite frankly have used passwords hate them. But presently, there really aren't any alternatives to password replacement schemes. People just want to log into systems, and they want to know that their information is being protected and not exploited and what have you. So frustrated users really just want to log in, and some sense of that is really the xkcd.com, their famous, infamous illustration, if you will, about all the sophistication that a password has to go through. At the end of the day, users just want to use the system. So other than just knowing that kind of passwords have been this archaic thing, what's really the problem? Well, the problem is there's kind of two different camps. And in one camp are really like the users and usability experts. And those individuals tend to be very optimistic about security and authentication in general. They just think that it works and that there's really no problems, or that when they do know of issues, it doesn't really affect them until it does. Whereas security experts tend to focus more on the scrutiny of the security and the longevity of that. They tend to focus on the practical issues rather than deployment. So really those things that matter to IT administrators and the end user in general, they tend to neglect those. Whereas biometric experts are kind of in their own pocket on their edge cases, and they focus on false negatives, naturally occurring false positives, and really they try to develop intelligent, adaptive adversary ways and how those things can be mitigated. Password replacement originators downplay features on their scheme that doesn't provide it. They basically shut it off as, oh well, we don't absolutely have to support that, or that edge case isn't applicable to us. So really, I mean, at the end of the day, password replacement schemas don't cover everything. Some are too broad, but not deep enough, and others are too deep and too narrow. So it's kind of a mixed bag, if you will, about which password replacement schemas are a fix-all, if you will. So yeah, the battle between security and usability yet again exists, but it tends to be a trade-off that really you have to gauge. So that's really why the framework was established to better gauge all of this. The framework proposed by the University of Cambridge really establishes a benchmark and kind of sets the de facto standard across the spectrum of all objectives and kind of intents and purposes that need to be met within a wide range of scenarios before it can be adopted widely. Before we kind of get into a little bit more of that, of the solution, let me just point out some limitations or scope, if you will, of the problem. So their framework really is intended for human-to-machine authentication. It is not intended for machine-to-machine authentication. And some examples of that, if you will, are things like cryptographic protocols. So think of your public key certs, things like CAC cards, exchanging email certificates, or even sometimes SA accounts and whatnot, where you have one machine might have a service account for another machine to install some software or something. So we're not necessarily talking those type of environments. We're just talking about really evaluating a legacy password replacement. I go in once, I do this one thing, and then I move on. So we're just talking about that. And I know that this brings up a lot of things of where, okay, well, NIST recently has published, everybody has to go two-factor or multi-factor authentication. So this paper does not look at multi-factor authentication. It essentially looks at just one factor. So the authors, again, developed a framework which has metrics in it, which highlight the benefits or characteristics that are important. As we've discussed, it's really broken down into usability, security, and deployment. So obviously usability and security are kind of the predominant ones, but deployment is just as important, because if we can't deploy this technology across the spectrum, if you will, it's not going to be used. And with that, we have, again, 25 characteristics that are kind of unique and still broad to where they matter to everything. Compare and look at. This figure here basically is the comparative evaluation. This is the large results table, if you will, and everything on the left there with an arrow is essentially something that we're going to look at. But essentially, when you look at this, there's about 4 different types of metrics per each segment. And what we want is green blocks with solid dots. Those are preferred. But really, anything on the line that is red is a very bad situation. So up at the top here, we have the usability, deployability, and security. And on the right, we have the category and the schemes. In general, we want replacement schemes that aren't worse than the existing password. They don't have any red blocks. They offer more benefits than legacy passwords, so they have black circles. And they don't have any white space. So let's go ahead and look at legacy passwords. So on the web, users typically are overwhelmed. On average, users have about 25 online accounts and only use about 6 unique passwords among those accounts. And up to 50% of websites don't appear to even hash passwords at all, which is mind-blowing given that it's 2019. But some of the pros to really having just a grayed-out password is it's quite usable. There's nothing to carry. It's resilient to theft. It's easy to read, simple to implement. It's very accessible, which can somewhat be a problem. But really, users experience minimal input errors, and it's not difficult whatsoever. Where we do know passwords are kind of insufficient is that they're purely memory-based. Again, you can forget them. You have to write them down. That's obviously a no-go. But so they're kind of poor on security as well, right? As we have passwords and passwords continue, people have done exploits to them or can just run them through a server farm and basically reproduce your password pretty fast. And so as password complexity continues to grow, exploits also continue to grow. This illustration here is just kind of showing, all of the crazy cases that you have to have for passwords. So here we're going to look at a password manager. In particular, we're going to look at the Mozilla Password Manager. Firefox offers this feature that you can, remember a password that you entered into a website. It encrypts that password within its back end, and then it requires a master password to access that. So you can see that you go to a password and you log in with a username and a password, and you can either save or not save it. And next time when you go to that web page, it'll just go ahead and fill all that information out, provided you give it your master password. This is good. It can provide users with a little bit more easier to use thing. They're using now different passwords for each website, and they only have to remember one password. And this is good if you can sync, say, Mozilla with across all of your computers. But would you necessarily do that in an internet cafe? Probably not. And really, it requires only one password per session, so that's nice. You can just log in once and be done. And it's quite on par with deployability. It's not too bad. It does have some minor browser compatibility issues, but it is pretty good. The difficulty is this can be catastrophic if you lose your master password. There's no way to recover it typically, and it's not necessarily supported by all browsers. Not to mention that attackers can still target infrequent typed master passwords. That's not going away, just as our previous situation. Really, because of that, it's susceptible to malware attack and capture, even if the connection is TLS or SSL, if you will. You can simply look at data packets going back and forth and eventually realize that, okay, here's where the password's at. Now, with federal sign-on services like OpenID, or there's others out there, if you will, like OAuth, and OAuth is a very popular. Really, these things were considered to be holy grails for users, and users, need not ever remember a password. Their whole concept there was essentially you have a service on the right side here, if you will, and the end application on the left side, and the user would authenticate. It will go to the application. That will come over and it will authenticate against the service. It will basically exchange some information there behind the scenes. And at the end of the day, it will send a key or a token, if you will, back to the participating party. So the user is essentially logging into the provider. And really, the application is seamless and doesn't see that. Now, the beauty in that is that the user doesn't have to log into each individual website. He just has to specify that on his provider's back end. The difficulty with that is now it's susceptible to major exploitation. This system basically provides easier use. Passwords only need to be typed really at the identifying provider's website, and passwords can be accessible from any computer, right? You don't have to have any kind of specific software installed on the browser or whatnot. Now, some cons to OpenID is it poses some significant challenges, if you will, with its interface. It's not necessarily intuitive on the deployment side of the house. And it raises larger concerns to adoption, standards, and really trust. I mean, if I'm an application developer, am I really going to trust OAuth to authenticate? I mean, I'm pretty much leaving the front door to them. And it can be exploited with cookies and malware and really phishing, if you will. So it has some privacy concerns for non-technical users and even technical users alike. But overall, it's pretty strong, provided you can get around some of those larger deployability issues, and again, some of those security setbacks and trust setbacks, if you will. RSA is really kind of been the long-established market leader in hardware tokens. Hardware tokens basically store secrets on a non-tamper resistant module that you have to carry with you. And the most commonly sold model are the two on the right. And those change seeds, if you will, every 60 seconds. So the screen's always on and they're always changing. Or you might have to push a button to see the numbers. But in March of 2011, attackers actually compromised the RSA backend, allowing all the seeds to be publicly known. So after that, they actually had to establish a PIN in conjunction with the generated hardware token key, so they could ensure that their system isn't going to be compromised. The irony there is it kind of sounds like they had to add a password, right? Their token system didn't really work well. Nevertheless, tokens are quite resilient, actually. They do improve a lot of security features that other systems or authentication methods just can't provide. And with the addition of a PIN, it is incredibly secure. We assume the device can't be really exposed to any kind of malware or phishing or anything of that. So it's definitely a hardened item, which is nice. Some cons with the system is the schema really requires a new token and pin per user. So this is not easy to remember. I mean, we all have a bajillion pins as well to remember. But two, it's expensive. Also, blind users can't necessarily read the code off of the token, right? So that's a little difficult there too. And quite frankly, a user must still transcode the passcode onto the screen. So, and the back end is crazy. You would have to absolutely rehaul your entire server backend, so deployment can be quite a nightmare. At the time of writing this, I just looked up the cost, and for a particular application, it costs approximately $32,000 to implement this system, and that's just including the proprietary software, if you will, at the deployment level, and then it costs an additional $100, if you will, for the hardware token, and quite a substantial license fee per user. So it's definitely not scalable, but passwords at the end of the day are the strongest thing that we have, given all of the metrics, if you will. So really this one's going to be looking at a mobile phone based application called Foolproof, and Foolproof was there to essentially solve phishing. So Foolproof is another token based scheme, but this time it's actually on your phone, and it comes with some special codes and crypto keys in the form of software. So a user basically selects from the whitelist on their phone what they want to do, what app or what website they want to go to, and the phone talks wirelessly to the browser. It launches that site, and it does that whole process using TLS, mutual authentication, and so really it ensures that the phone and the website is secure without any phishing or injects. That's good. However, the user still must enter their username and password once they actually get to the site. So this is kind of an augment, if you will, to username and password. So some benefits to having this type of phone-based scheme is that the attacker really can't hack. The authentication is pretty solid up until the point where it gets them to the website. So some cons are users still must have their phones, and it really doesn't solve the username password problem that we've been trying to combat this whole time. And the recovery mechanism is really difficult. If you lose your phone or your key just goes kapooey, what do you do? So handicapped users might have some issues with this, but nevertheless, deployment is a huge issue here. Usability doesn't really improve, and security, yes, is increased, but at what cost? My favorite biometrics. So biometrics are really, the what you are kind of method of authentication. It leverages you, your physical and behavioral characteristics. So biometric devices are rated as either supervised or unsupervised. So like your home tablet, if you will, or your phone is an unsupervised type of biometric. And a supervised biometric might be what you'd see at an airport or the jail, somewhere where they actually have to identify you. The pros to biometrics is there's no secret needed. You don't need to remember anything. You don't need to carry anything. It's just right there. It's on you at all times, provided you have a finger. Now, the difficulty is there's really no suitable recovery option, right? So if you can't authenticate for whatever reason, how do you recover your authentication? You can't. And hardware is quite expensive and still even prone to human errors. Commercially available hardware is really limited and expensive. To get really good grade fingerprint recognition hardware and software, you're going to spend a decent dollar. But with that in mind, you also have the difficulty of the back end. So sometimes you're going to have to rehaul the servers or what other in means. And on the internet, that's just a big concern. How do you unify all of this software across the spectrum? How will you guarantee everybody has the same software and hardware? And really, the registration of biometrics is not practical. It's a serious issue. It lacks logistically. I mean, how can you verify somebody's fingerprints? And there isn't really a public database for this. You wouldn't be able to really start one, and quite frankly, you might run into some HIPAA constraints. I'm not sure. But nevertheless, biometrics are good locally, but on the web and whatnot, where you have a mass scale, it's just not good. It's not deployable. The security, you don't really get much benefit there. You do get some usability, that's for sure, but it's not even perfect comparative to passwords. So to conclude, I just want to say, no schema the team evaluated was perfect, and nobody came near perfect. That's very apparent. And that was true with all of the schemes. And not a single scheme was dominant over legacy passwords. No row in that table that I initially showed, or that you find in the document, is free of any red blocks, which is bad. And quite frankly, it really comes down to giving up one set of compromises and trade-offs in exchange for another, right? What do you find good in authentication? Another person might not find good in authentication. So just keep that in mind. And the paper suggests that legacy passwords are really the best thing we collectively have right now with respect to usability, deployability, security, those 25 dimensions, if you will. And it's kind of really no surprise to me, but I mean, if you think about it, other schemas are now being used in conjunction with legacy passwords. So two-factor authentication, if you will, is very popular right now. And this paper doesn't, again, go into the depth of that, but it actually makes sense, right? So where one scheme might have benefits and the other might have not have those benefits, by combining the two, you hit all of those benefits. The problem, though, is again, we just want one dang on thing to do. We don't want to have to use all these things in conjunction. We really just want one method. Also keep in mind that when we go to authenticate in very critical times or important moments in our lives, really we have to do multiple schemes anyways, right? So consider when you get your driver's license, or you have to apply for a marriage certificate, or you're applying for a bank loan. Typically when you go through those things, you have to have multiple statements of proof saying you are who you are. And even then, sometimes things aren't accepted. So really in important moments where authentication matters, there's typically a human always there. We can automate it as much as possible, but at the end of the day, somebody is evaluating it based on what you've presented them or what you've sent them or given them. Perhaps in the future we'll use DNA or something again that kind of addresses all these things, but I don't really want to prick my finger, and if you're a twin like me, God knows if anybody will tell you apart. Anywho, if you have questions, I definitely welcome them. If you could, just please post them to Piazza. The link is provided there. And again, all of the links are also provided in the comments of this video. And thank you for watching and hearing me ramble on. I appreciate it, and you have a good day. Bye-bye.